Honors Algebra 2 Pre-Calculus. We are doing a homework review for the COVID-19 Chapter 6 review homework, or the Chapter 6 like shortened, truncated homework for the COVID-19 school closures. This is 6.1, number 19, page 461 in the textbook. I'm not going to write the paragraph up, but I terribly drew the diagram, so let's walk through this. A tree stands on a hillside slope that is 28 degrees from the horizontal. From a point 75 feet down the hill, the angle of elevation to the top of the tree is 45 degrees. See the figure. What is the height of the tree? Okay, so we want the height of the tree. So really what's happening here is we're going to be looking at this triangle, okay? And we're going to talk about what that's going to look like. Okay, so we're looking at the green triangle. So let's figure out some things that we know that are not listed here, okay? The first thing I know is that this little red angle is 28 degrees, and since this blue triangle is a right triangle, I know that the 28 and the 90 degrees and this other mystery angle have to sum to 180 degrees, meaning that since this is already 90, these two have to sum to 90 degrees together, which is going to make this angle a 62 degrees, right? I also know that we're assuming the tree is standing straight up and down because they would have told us if the tree weren't vertical. So that means that this is a linear pair. So if this is a 62, then this angle here has to be what's left that is not a 62, right? So 180 minus that 62, right, for lack of a better way to say it. So this should be 118 degrees, right? So that's this angle. In the green triangle, I have 118 degrees. Also, because I know this whole angle is a 45, this blue angle, if this part is a 28, I can find this little green angle as well, right? The little green angle and the 28 have to sum to 45, right? Which should mean that this is a 17 degrees. So now let's, and we already know that this long side here, right, from here to here is a 75. So let's redraw the green triangle, okay? Just the green triangle with what we know and what we want, okay? Not to scale at all, but we want h, right? We want the height of the tree. I know that this angle is 118 degrees. I know that this angle is a 17 degrees. And I know that this side here, like down the hillside, is 75 feet, right? So I don't know the third angle yet, but I can know the third angle because I know the way that the sum of the angles in a triangle works. So let's make a list of things we know. I'm going to call this angle big H because it's opposite the thing I called little h, okay? I'll call this angle big B for base of the tree, which makes this side little b, right? And I'm going to call this angle big T for the top of the tree, which would make this little t. So now let's make a list of the stuff that we know and the stuff that we don't know. So we don't know big T yet, but we'll deal with that in a sec. We do know big B is 118 degrees. We do know that big H is a 17 degrees, right? We know little t is 75 feet, right? We don't know little b. We do know that little h is the thing that we want, right? So my argument is that since this is in 6.1, they definitely want me to use law of sines, but also if I knew big T, I would have a pair, and I could use that pair to find little h, right? So in order to find big T, essentially, I just need the sum of these two, right, which would be a 135, right? So big T should be a 180 minus the sum of that 118 plus the 17, right? Which again is a 135, and then I subtract that from 180, and I should get that this is a 45 degree angle. Oh, I could have also done that another way. This is a 45 degree angle, so this also had to be a 45 degree angle. That was stupid of me. Come on, Hogan, that was dumb. Okay, cool. Sometimes these things happen. Either way, I get that it's 45. So, I really didn't end up needing the 118 at all, but again, you can't always know that when you go in. So really all I needed to do was find this 17 and find this 45, which I could have found in a much faster way than I did, but sometimes we don't realize it till it's too late. So then I'm going to set up the law of sines. So little h over the sine of big H, which was the 17 degrees, is going to be my little t, which was the 75 feet, over the sine of the big T, which was the 45. So my little h is going to be 75 times the sine of that 17 degrees, divided by the sine of 45 degrees, right? And I'm going to type that in my calculator and get my little h, and remember that it is in feet, right? Make sure you're in degree mode. Depending on what you've been doing in your calculator, there's a chance that you're in radian. I've been doing a lot of calc lately, so often I'm in radian, but thankfully I'm in degree mode. So I'm going to type in 75 sine of 17. I don't need to put the degrees because I'm already in degree mode, right? Divided by sine of 45, and I'm going to hit enter. And I'm going to get that it's 31.010 or 0.011, depending on whether you round or truncate. So 31.01, either 0 or that last digit could be a 1 if you round instead of truncating, right? So that's my answer for the height of the tree. So again, I definitely did some extra work there that I didn't have to do, and you're going to find that sometimes in a problem that you could have made your life a lot easier. So What I should have done in the first place, to be honest, is looked at this green triangle, drawn it here, made a list of what I know and what I don't know, and then thought of ways to find it. That's probably much smarter than just going in blind and doing a lot of work before I know what I need. But there you have it. That's 6.1, number 19 from page 461.